When I was developing the Cabins game back in the 80s on the Z80 I got the gameplay working, but as I added the intro screens, I found I was running out of space in the 16K of memory. The game was never finished, and eventually the tape stopped working. And now 40 years later I'm rebuilding the game. At that time the only resources I had were my ZX81 manual, a book on Z80 coding, and magazines like Sinclair User. There was no internet, and I didn't know anyone else who was writing code for the ZX81. But now all that has changed. The internet has many users who are interested in the ZX81 and Z80 coding. Now I know about file compression. If I'd known about it then, I might have been able to squeeze the game into 16K of RAM and finish it. So in this video I'm going to look at file compression and see what kind of space saving I might have been able to make had I known about it. Phase 1. So first I've cut down the game to code that loads a screen from a binary file and also includes all the binary files for the different screens. I'm going to attempt to compress the screen files and see what saving I can make. When I compile this for the ZX81 I see that the P file is 10 kilobytes big, quite a big chunk of the 16K. Looking at the binary files for a screen in HexEdit, each screen is 768 bytes and has 32 by 24 characters in it. Running the code in the 81 emulator, it loads the first screen of the game. Phase 2. The ZX81 display is made up of 20 rows of 32 characters. At the end of each row is a new line character, character 118 or hex 76. While just having the data for the screen in the binary, another way I could have done this is to include new line characters in the binary. This would add 24 bytes to a file, one character per row. But the advantage of this is that the code to load the screen into the screen RAM is simpler. I can just use one LDIR instruction to load the data in. So it's faster, the code is simpler, but the trade-off is the files are slightly larger. Looking at the file in HexEdit, you can see the 118 or 76 hex characters in the file, and the file size is now 792 bytes. Compiling this version of the code gave me a P file of 10.3 kilobytes. Phase 3. Getting on to file compression, a couple of algorithms came up that looked suitable for the Z80, RLE and LZ4. There are others, but I decided to look at LZ4. There were a number of code samples on the internet and it looked well supported. I downloaded an LZ4 file compressor and compressed all the screens to the LZ4 format. I used the files without the new line characters. I found some LZ4 code to decompress the screens on GitHub and plugged this into my print screen routine. I couldn't directly load the decompressed data into the screen as it would break the display without the new line characters. So I had a buffer area of 768 characters to load the decompressing data into, then wrote this data into the screen RAM without overwriting the new line characters, as in phase 1. Looking at the P file for this method, I had made quite a space saving. It came to 7.23 kilobytes. That buffer was taking up quite a bit of space though, and having two steps was going to slow the code down. Phase 4. I decided to compress the binary files that included the new line characters. This meant I could uncompress them directly to the screen RAM, wouldn't need the buffer, and not have two steps, and the code should run faster. The trade-off was I would have more bytes in my base binaries. However, I was saving on not having the buffer, and the code to decompress and write to the screen was smaller. Now the P file came to 6.77 kilobytes. I had saved 3.23 kilobytes from my original phase 1 code. So in conclusion, whether the space saving would have been enough to finish my ZX81 version of Cabins in 16K, I don't know. I will only find out as I carry on working on the game. If the compression doesn't take the game under 16K, I probably won't use it, as it just adds complexity and slows things down. The other thing to consider is the speed of the code with these different methods. Without plugging the code into the actual game, I can't tell how much slower the versions with decompression are. It might not be much, but we will see. So now I've started learning about file compression for the ZX81. It took 40 years, but it could come in handy. Hope you found this interesting. Thanks for watching.